For the purpose of this beginners video, we're going to talk about the three basic categories of data types. Now, the first one is going to be the integer types. So basically, I'm going to write a little comment. So now a comment is just going to be code or a statement that is going to be ignored by the compiler. Now this is just going to help me to give myself some little notes so that I have everything well structured. Whenever you want to do that, you basically have to think about using comments. Now, the first type of data types that we're going to talk about are known as the integer types or the integer types. So now for the integer types, we basically have the following data types. So we have the int data type. So this is going to be used whenever we want to store integer values. That is, this is going to be signed by default. So meaning we're going to store positive and both positive and negative numbers as well as 0. So remember, a variable is going to have a type and a name. So for example, we have to give this variable, for example, if you want to store the age of a person, the name of this particular variable is going to be age. Remember, our names have to be descriptive. All right, they have to describe what value we're trying to store into this particular variable. So hence the most appropriate choice here is going to be age. So we can declare a variable age. So the int data type is going to enable us to store both positive and negative numbers as well as 0. So we also have another type which is known as, while we're still on int, so what we've done here is that we've declared a single variable. We can also declare multiple variables on the same line. So we can say int a, b, c. So what I've done here, I have declared 3 variables. Now this is the same thing as saying, so int a, you can also do int b on a separate line, and then int c on a separate line. So what I've done here can be done on a single line as shown here. So you can either declare a single variable. So all the variables that I've declared here in one line are all of type integer, right? So you can do that, or you can declare them on separate lines. So it is an issue of personal preference. So that is for the int. So we also have the char data type. Now the char is basically going to be defined as a small int. Well, the int is going to be represented with 32 bits. Now 32 bits is about 4 bytes because 1 byte is 8 bits. So an int is going to be represented with 32 bytes. A char is going to be a smaller version of the int. It is going to be represented by 8 bytes, all right, by 8 bytes or by 8 bits or 1 byte. That is a char. So you can basically store numbers. This is going to be assigned as well, meaning you can store both positive and negative numbers. Now the minimum negative number you can store in a char is going to be -128, and then the maximum positive number that you can store in a char is going to be 128. So a char can also be used to store single characters, such as maybe the first letter of the alphabet, which is A, or the second letter of the alphabet, so an underscore and all that. So you can also use a char data type to be able to store those. So for example, we can say char, and we can say char, maybe we can say char score is going to be equal to 65, right? We can do that. So we can store numbers. The minimum negative number that we can store with a char variable is going to be -128, and then the maximum value is going to be 127. So you basically have to be within that particular range. So you can also use the char variable to store, or the char data type to store a single character. For example, the first letter of someone's name. So you can basically say char, and then you can say first letter. Char first letter is going to be equal to. So you basically have to use single quotes here. Throw in your single quotes, and then you can say A, for example, as someone's first letter. So what we've done here, so in the first 2 lines we've just declared variables. Now in the 3rd line and the 4th line, or that is the 10th line and the 11th line, what we've done is that we've also provided initial values. So we've declared and we've initialized our variables. So we've done 2 things at the same time. So we've also provided initial values to our variables. So basically that is what we can do. That is the char data type. So we also have another one that falls in this category of integer types, that is going to be known as a short data type. Now we'll look at, we'll look at how you can establish the minimum value and the maximum value that you can store in a particular data type a little bit later. And now let's just talk about these things, generally. So a short is also going to be a smaller version of this int data type that we have here. It's going to be represented by 2 bytes, or maybe 4 bytes. It is going to depend on the system or the operating. It is going to depend on the system or the environment that you are using, as well as the compiler that you are actually using. So it is going to be platform dependent, and it is going to depend on the compiler. So on one compiler, the space that these variables are going to take in memory is going to be, might be, different from another, from the amount of space they're going to take if another compiler was to be used to compile this this program, right? So a short is going to be a smaller int as well. So we can say short int. So we can either go short int and give our variable a name. So for example, we can call it height, for example. Now height is not a very, it's not an ideal example, because height can be a real number. You can have a height of 11.4, and basically integers are not going to have those decimal points. So height is not a very good variable. So maybe let's say short int number, and then we can throw in our 10 for our 20, for example, like so. So we can either go short int, or we can get rid of the int and just say short, right? So we also have another one that is going to be a long. So a long is going to be what? So to declare a long, well, we are supposed to say long. Maybe we can just say number 2, like so. And then basically this is going to hold a much bigger number as compared to the int. So you can either go long int, like so, or you can either go long. You can either say long int, or you can get rid of the int altogether and just have long. The same way we did for a short. So we have long number 2. Now an example of a number that you can store in this long data type is this particular number that I'm going to throw in. All right, this particular number that I'm going to throw in. Now this number has a suffix. As you can see, it has an L at the end. So what the L is going to say, the L is not part of the number. What the L is trying to do is that it is trying to tell our compiler, whenever we're going to compile this this code, it is trying to tell our compiler to treat this number as a long literal, right? So we basically throw in that L. It is not part of the number. It just tells the compiler that this is going to be treated as that this has to be treated as a long literal, right? So we also have a long. Now we are going to store very big, very big numbers in this particular data type. So we can say, for example, long number 3, like so, right? That is, so an example of a number that we can store in this particular data type is going to be this very long number that I don't even know how to read because I'm bad at reading numbers. But hopefully you can see how big these numbers really are. So we're going to establish later on the minimum and the maximum values you can store in all these data types, and then you're going to see which of the data type, which of the data types that we're going to list is going to be more appropriate to store the value that you want to store at a particular instance. So we have the suffix LL. So what this is going to do is that it is going to tell our compiler to treat this particular number as a long literal. It is not part of the number. It is just telling the compiler that, okay, treat this guy as a long literal, right? So these are the integer types. We also have the second type, the second type of variables that we can declare, that are known as floating point, the floating point types, right? The floating types, or the floating point types, right? So we can say floating, again, I use my comments, floating point types, right? So we have floating point types. So basically we have 3 data types under this category. The first one is going to be a float. So this is going to be, how now we want to be able to store real numbers like, the height, someone's height, someone's weight, for example. You basically have numbers with decimal places. Now a float is basically going to be a single precision number, meaning it is going to basically have, we have different ways in which real numbers can be represented in the computer's memory. So we have single precision floating point numbers and double precision floating point numbers. Now I'll talk about the differences, in a few seconds. So, but if you want to store a real number, you might think of using a float data type, because of course you're going to have decimal points. So float, so we can just say float. For example, we can say length. The length can also be a real number. Float length is going to be equal to, so I can throw in my 10.34 like so, and throw in that particular number. So float length. So we also have another one which is going to be, so a float is going to be represented with 32 is going to be represented with 32 bytes. Now of course that is going to depend on the platform as well as the compiler. So we have that double like so, and then we can maybe, let's say, double then someone's height, for example, and then we can throw in someone's height and say maybe 23 point, that real number that we've thrown here, that we've thrown here. So we also have we also have what is known as a long double, that is going to be represented with about 80 bits or more. That is going to depend again on the compiler as well as on the platform. So a long double, what good name can we give to this? So maybe we can say length. Now I'm running out of names, so I'm just going to say length 1. So length 1 is going to be, for example, it's a very, very big number that you can store in here. So a very, very big real number that you can store. So we can declare that. So we basically have the floating point types. Now back to the issue of single precision and double precision. So now by single precision, we mean a float is basically going to have an accuracy of about 6 to 7 decimal places, right? When beyond that, we are going to have we're going to get numbers that are going to be inaccurate. So by precision is how we can model a real quantity, right? Like the length of something. So how accurately we can model a real world quantity, such as the length of something, the height of something, and the width of something, or that. So how accurately can we measure that? So basically a float is going to have an accuracy of about 6 to 7 decimal places, and a double is basically going to have an accuracy of about 15 to 16 decimal places. Now this does not mean that a double is a wiser choice to use because it is more accurate. It is going to depend on what you want to use, the application that you're building and what you want to do. A float is going to take up less space, but it is less accurate when compared to a double. Now whenever accuracy is not a big deal in your program, it is the more natural option becomes to use a float. Becomes you're going to use a float. Now if your application relies heavily on precision, and you need that precision, you might want to use a double. A long double is also a long double precision floating point number, but it is going to take up more space in memory. Of course, it is going to depend on the compiler, and it is going to depend on the platform, right? Now some of these data types, C had one major improvement. It is known as C99. So some of these data types, such as the long, were made available in C99. So if we are going to compile this program, well, we have to specify that we want to use, the C99 version of the compiler, right? We want to use the C99 version for us to be able to, have these variables, recognized. So below that, these variables were not provided. Right? So what we're going to do, if we are going to compile this program, we have to specify that we want to use C99. So the long was made available in the C99 update, right? So these are some of the data types that we have. Now the third type only contains one variable, one type. It is the void type. Now the void, we've already seen our void. So void is basic. It is going to have the void, the void type. So void is just going to mean, it literally means no data type. Why? Right? It means no data type. It is not an int, it is nothing, right? Of course, this is mostly going to be used as a return type, as the return type of functions, for example. Like we saw in the previous video when we were talking about the return type of the main function.